Okay guys, so this part finally will be how to make the load balancer, aka the reverse proxy. So that's going to take a incoming request and give it to one of the servers in the backend, right? So we're going to use the package in Golang to make this reverse proxy, and this will be the final video on how to make a load balancer. So without further ado, let's get into this. Okay guys, so we are on the final part on how to make a load balancer. In this series, we covered how to make the servers concurrently run in the background, right? So if you go back to this diagram, we covered on how to make these 5 servers run in one program execution. Now we need to do the load balancer, which gets the traffic from the client and distributes it to one of these servers. Now, a load balancer has many types of algorithms to determine where the request is going to. Some algorithms calculate which server has the most CPU power or most strongest to take the more of the traffic, and they do this by weighting the servers. They put weights on the servers, and depending on the weight, higher the weight, the higher the traffic it can handle. But we're just doing round robin, very simple. So what a load balancer is it's a reverse proxy. And to know what a reverse proxy is, you need to know what a proxy is. So let's take an example of you're trying to watch a Netflix show that's not in your region, right? So you want to hide your client information and turn it into something new, like say something from the UK, right? So the Netflix server doesn't know anything about your client information. It knows just only about the proxy, right? A proxy is a middleman, and based on the configuration of your proxy, you could set it to UK, whatever. The servers, Netflix servers, will send you UK content, UK show contents. And yeah, so a proxy hides your client information. A reverse proxy hides your backend information. So a reverse proxy, the client, which is you, requests a website, and there's a reverse proxy is a middleman that's going to send your traffic to one of the servers in the backend that you won't know. You won't usually know. Um, and yeah, you'll get your content based on whichever server you hit. That's the point of reverse proxy. It takes your request and it kind of abstracts servers on the backend and feeds it to you as the middleman. So in a load balancing reverse proxy, it's made for optimization of the web traffic. So it makes sure that your request is going to a server that can handle it. But yeah, that's just it. Hopefully that made sense. But yeah, let's go into coding this. So if in the load balancer directory that we created in the first video, we can make a file called loadbalancer.go. Okay. And in here, we can go ahead and make the package, of course. Say load balancer. And we can now make, similar to servers.go, how we made a struct, we can make a load balancer struct. Now this load balancer struct is going to take a property of reverse proxy. And this is going to be reliant on the HTTP util package. So you can just make the import, it's going to do it for you, and then dot reverse proxy is going to give you the reverse proxy property. Now, furthermore, the load balancer needs to know which endpoint to hit, right? So localhost port 8080, 8081. So we're going to need a list of these endpoints. So we can say type endpoints. We can say struct as well, and we can just give this list property, and we can say this is going to be a slice of URLs. Since that's what an endpoint is, we can make this a pointer to them. And just to make it easier for us, we're going to make a global variable. This will be called base URL, and it's going to be equal to http :// port 88. Now here we can mess around with this. We can do some string concatenation. We can make it 8080 if it's server 1. If it's server 2, it could be 8081, server 3, 8082, and so forth. So that's why we're using that. And now we want to actually make the load balancer. So we're going to go ahead and make a load balancer function. And so if you want to make a load balancer, let's just give it a parameter of how much servers you want your load balancer to distribute traffic to. So we're just going to do an amount parameter. It's going to be of int type. And yeah, so that's going to be it for right now. Now we're just going to instantiate objects. So our load balancer and our endpoints is what we want to instantiate. Load balancer, endpoints. Okay, nice. Now, similar to how we made a server in servers.go, what a load balancer is actually still a server that runs on a different port than these. So we can go ahead and make a server within here as well. So let's just make the server plus the router. So our router is going to be using the HTTP new serve mux function. And then that HTTP package should be imported for you. Furthermore, our server is going to take a http.server struct, and this struct is going to take an address, and the port is just going. I'm just going to make it 8090. The handler is going to be our router. Okay, that's pretty good. Now this is going to have to take handlers, right? So handler functions. So our handler functions, it's going to be something like router dot handle func. And remember, handle function takes in an endpoint. Here we're just going to say check, right? Check which end. Let's see. We're just going to say load balancer / load balancer. And then in here, we're going to. So this is the signature of a handler, right? We're going to, instead of doing it within this code, we're going to branch it out to another function. So let's just make a function called make request. Okay, so this is like modularizing our functions. And now the important thing is this function has to have a certain signature to be accepted within here. What it is W for http.responseWriter, and then R for pointer to http.request. Okay, so now we can actually go ahead and put in make request in here. Okay. However, I think we're gonna actually do something different than this. We're gonna actually make this return a handler. So this is gonna return a func with these. So it's gonna return a function with this function signature. It's gonna return this, and what it's gonna accept in the parameters is something different. Instead, it's gonna accept our load balancer. So we're gonna say lb for load balancer. It's going to take our endpoint list, so we're going to say endpoints. Okay, and I think that's it. So now in here, let's make it return that function, right? So return func. Okay, so now it's going to return this function. Now all we can do is just give it the parameters it needs, lb and ep. Oh, and make sure they are addresses to them. And there we go. So that hopefully that makes sense, right? So a handle function has to accept a function that has this function signature, and since we're making a return that, it's totally okay that we can call this make request inside of this handle func argument, since it's going to return the right function signature. So that's good. Now in here we have to write the logic for the load balancer to visit certain endpoints, right? However, we need to make the endpoints before we actually can actually visit this endpoint load balancer. Okay, so creating the endpoints. Okay, so it's pretty easy. Since we have a amount argument here, we can use that. We can say I is equal to 0, I is less than amount, and then we'll say I plus plus. What's going on here? Age expression. Okay. Oh, I forgot my semicolon there. Okay. Now we can go ahead and go into EP. We can say endpoints, not endpoints, endpoints.list is equal to append ep.list. Now what will we append here? We're going to append the base URL plus the I, but this I has to be converted into a string. So say string convert dot. Oh, I'm sorry. Wait, these have to be URLs, right? So it's a bit. All right, let's make a function to do this. So let's say func create endpoint, and what it's going to take a string. So we're gonna say endpoint string, and what it's gonna return is a URL dot URL. Okay. So yeah, so this is gonna take the endpoint, right? So it's gonna say, trying to think, link is equal to endpoint plus index, and this is gonna be an integer, and we're gonna say index, and it should give me an error, right? Because I guess not. But okay, so we're gonna say URL is equal to URL.parse. Gonna say link here, and we're gonna return URL. Hold on, what's going on here? Oh, it's giving me an error. So let's just comment this out for now. Okay, now we're actually getting errors. So mismatched type, so string and integer. So we can use the string convert package, and we could say integer to a string. So let's just import that, should go there. Now this is returning a URL and an error, so we have to put another variable here. We can just set it to what's that called? Underscore. So we can just not error handle, it's fine. And then we return the URL. So now within here, our for loop, we can just call the create endpoint, and it will take the base URL, right? And then it's gonna take I, and we also have to append it. So we have to say ep.list is equal to append. Okay. This is going to take two things. It's going to take ep.list. There we go. All right, so that's going to now populate the list of URLs. And now we're good. This is yelling at me because it's not used. It's pretty easy. We can just call. I guess we don't need it. I guess we do. All right, listen and serve. So we can say log.fatal server.listen and serve. Okay, that's good. Now we have to write the logic for the load balancer to visit these endpoints. So we're gonna go into make request, and everything that goes in here is gonna run when this is hit, this load balancer endpoint. So within here, what we want to do is we have to use this this HTTP util function called new single host reverse proxy, and this is going to take a URL. This is going to be the endpoint. So we can say ep.list at 0, and that'll be fine. Now what are we going to give this value to? Is we're going to give it to lb.reverse proxy, and set that equal to that. See why it's giving me an error here. Let's see. Okay, let's set it equal to a pointer. There we go. So that's good. So now this we can use this and we can say lb.rev proxy dot listen and or dot serve http. Now we're good. We can just give it a port, or no, I'm sorry, not a port. We can give it the response writer and the request. So now this is going to give us server one. Server one. It's going to be 8080. And then if I change this to list one, right, the second element in the list, it's going to be 8081, and so forth. So if you're catching on now, we're going to have to make it so we can shuffle through every single endpoint in the list. So the way we can do this is we're going to make a function here. We can make a global variable called index, and it can set it equal to 0. And every time this function is hit, we can just use the index, for example, right? And every time this is hit, we can just do index plus plus. And then we have to set a limit, of course, to modulus 0. So we can say index is equal to index modulus 4, but if we wanted to make it dynamic, we can do length of endpoint.list, right? So if, that would probably work, guys. I don't know why I didn't do it like this actually, but what I'm gonna do instead is can make a shuffle function. So we can say func e for the endpoints, right? This is a method receiver for the endpoints. We're gonna make this called shuffle. And we're gonna make this accept nothing. It's just gonna be an internal function that just internally changes the value of list. So what we will do is we're gonna do e.list is equal to, actually before I do this, let's set a temporary variable. We'll say temp is equal to e.list at 0. Then we say e.list is equal to e.list. So now this is removing the first element, and then we are now appending it to the end. So what happens is the first element is now appended to the end. So that is kind of a way to shuffle it back to the end of the list, and that's kind of like a pop. If you remember from servers.go, our pop function is very similar to this, but we're just kind of changing around the logic for the element to not be lost. Instead, it's just going to be put to the end of the list. And yeah, that should be good. So this is what I did. I did a shuffle function, and then instead of doing this index plus plus, and we don't even have to set a limit here. We're just going to do the first element, and then we're going to call the shuffle function. So we can just say ep.shuffle, and that should work. Less lines of code, and we can get rid of index equals 0. And now this should work. Let's go ahead and try and test this out. Create the endpoints, and yeah, let's go ahead and go into our main.go, and we can go ahead and call this. Just comment this out. So what you want to do is it'll automatically do it for you, but you type in load balancer, right? That's the package name, package load balancer. You say dot make load balancer, and you set it equal to the amount of servers that you have running in the backend, and we can just go ahead and run this. First, actually, we have to run our servers, so let's not forget to do that. So this should run the servers. Okay, and localhost port 8080 has server 0, which is server 1, but okay, server 2, so it's working, right? We have our servers running. Should be all 5 servers, okay? So now let's have our load balancer going. Let's also put the zoom up on here so you guys can see a little better. Okay. Now, we try out our load balancer on a different shell. Go here, say go run.main.go. Okay, it's running. Now we'll go to localhost port 8090 / load balancer. You see we get server 0, that's the first server. If we refresh, we get server 1, server 2, 3, 4, and right, that's the load balancer round robin style. So that's how you do it, guys. Now, how to check if the servers are healthy, right? So I know that's a main part of the program that a lot of people wanted. It's okay, we can go over that. If you guys just wanted how to make the load balancer very simple, this is how you do it. But yeah, let's go back into load balancer.go and let's go ahead and make a function to test a server. So we can say func test server. Um, Now this is going to return a boolean to tell you if the server is up and running correctly, right? So what we'll do is make a response and error function, response and error variables, and they're going to be equal to http.get. Now what this test server is going to take is going to take an endpoint, and it's going to be of a string, and it's just going to visit this endpoint. And if error doesn't equal nil, then we're just going to return false, okay? That means if there is an error, then obviously the server is not healthy, so you can go ahead and turn a false variable. Furthermore, if the response.status code doesn't equal to http status okay, then we also want to return false. If these things do not meet, then we can just return true for us to know that the server is healthy. So this is giving us an error because it's not used. It's okay. Now where to use this, right? We'll want to use it somewhere in here inside of our make request function. Now in Golang there is no while loop. Instead you have to use for loop. But this for loop accepts conditional, so it's kind of like a while loop. So we can say for test server, and we have the endpoint inside of the list, right? So we can just give it EP list 0. However, it's a URL, so it's gonna yell at us, I believe. Should be yelling at us, right? So it's saying we need it to be a string. So if you go here, the URL object has a string function, so you can just do this, and that will be good. So now it's just gonna return either, if it's healthy, we're gonna want to handle that. If it's not healthy, we're gonna want to skip that. So if it's healthy, this can run. If it's not healthy, so we'll just do a exclamation mark. And if it's not healthy, we just want to shuffle, right? We'll do ep.shuffle to skip that certain endpoint, and we'll skip it and go to the next one. So yeah, I think that's all we need. That shuffle. And yeah, that's okay. That's pretty good. Now, let's go ahead and see if this is gonna work. I think I'm missing something though. Oh, right, right. So we have the code to make sure that the server is healthy or the endpoint is healthy. Now, how to make the server shut down? How to make it shut down? Well, we'll actually have to go back to servers.go. Now, here within our make servers function, we want to add another handler. This handler is going to be of shutdown. Let's give it a shutdown endpoint, right? And it's going to accept these function with the same function signature as the handler. And we can just go ahead and inside here we'll do a w.writeHeader 400. So that means it's not good, right? So 400 status code. Actually, did I get that right? Is right header 400? Let's see. I actually forget. Oh yes, okay. So let's just copy and paste this from the repo. Um, if you, I'll link the repo in the description. But yeah, let's just copy and paste that. Okay, we can save that. And now the main thing is we're using this shutdown function from the HTTP um, package. So if you guys, not the HTTP package, but it's from the server property. So if we go here and we type in like server dot shutdown, should be a thing. However, it's just give me a bit of a problem. So you want to copy and paste this server instantiation and put it up above here before the handlers. Okay, so now we have no errors. So yeah, server has this function called shutdown, and that will gracefully shut down the server without causing the program to panic. So yes, use this function here. And now we can run our servers again. So let's just Control C this and make sure we have this to run servers. Okay, let's just run this. Okay, so now we can see we have 8080 up, right? Everything's good. However, if we do shutdown as the endpoint, okay, it's gonna stutter a bit and it's gonna be in a kind of idle state. So if we try to visit it again, it's gonna tell us that this page cannot be found. Eventually, the site can't be reached. Now, if we go to 8081, the site can be reached. So right now, our first server is down. So yeah, it works. The endpoint does work. Let's just run that one more time for everything to be healthy. And now we can go back to our load balancer. Actually, we'll just use this function right here. And we can call this, we can run this now. Okay. Now our load balancer should be up and running. It's going to be on port 8090 / load balancer. Right, so we have our load balancer up and running. Server is nice and healthy. However, let's go ahead and shut down server 2. Server 2 would be 8082, 012, yeah, 8082, right? So let's shut this down. Shut it down. Okay, so now it's going to be completely shut down. We can even just exit out of this. And we can go back to our 8090 loader, port 8090, which is our load balancer. It's going to go to server 3, server 4, server 0, 1. Now watch what happens here. So it's going to server 2, it's realizing it's down, and it skips it, so it goes to the next server. So that's how we do a health check, guys, and we skip and we handle that accordingly if the servers are up and running. So yeah, that's how you make a load balancer in a nutshell. You can add more features to it, feel free. But that's all we're going to cover for today, guys. And this code will be in a GitHub repository, and I'll link it down below. So if you liked it, please like and subscribe. Thank you, guys.